In this video, we're going to go through the building information worksheet. So, as we said before, when you first open it, you're going to see these comment bubbles everywhere. Read through these on your first go through. As you're going through as well, it's important to make note of this red text. I'm not going to spend this video rereading all of this red text because it's everywhere here, but it's important to read through it at least on your first use, because that will tell you how and why to do specific inputs. So user information, this again, this is just, it's not going to affect the numbers at all, but this will be displayed on the reports. Units, as before, do not change units after you've started doing anything. Once you select imperial for the project, leave it as imperial or metric if you're doing that. Project information. So yeah, anything you enter in here is going to show up on the results page. For weather data, you're going to see this red exclamation mark here. This means I haven't properly selected this yet. So that's kind of a warning to me. Once I do, let's say I'm in British Columbia and Vancouver, you'll see that red error has disappeared. And once I choose my city, all of these values here are automatically taken from the weather data saved. If you have any custom weather data, you can enter it in here. And that's what this note says. You can enter in any one or multiple of these inputs. And whatever you input, so right now, our outdoor temperature is 8 for Surrey. If I type -10, it's going to just take -10. Everything else is going to be the values from here because I haven't written in anything. But -10, the one that I have input, will overwrite that one. Project information, again, this is going to be displayed on the results page. Building attachment, floor levels, front of house facing direction, these are the same as before. If you want more information on those, hover over these notes and you can read those hover notes here. Front of house facing direction, is this value assumed? Again, this is just something that shows up on your report. It's not going to affect the numbers at all, this input here. The area and volume calculator, I recommend to spend a few minutes on. It's important also to click this button to make sure you understand how to specify the volume of a building, right? We do not include envelope elements in the volume, but we do include interior elements like floors and interior walls. Also, I recommend to read all of these hover notes here. It's a little bit more complicated than before. However, once you understand it, it's simple and fast, and it actually speeds up your inputs over here on the room dimensions worksheet. And we'll show you how that's done in the next video. But basically, this saves you from having to enter in all the areas of all the exposed walls, because if you enter in the height of the walls correctly, Excel is going to calculate the area for you. Also, make note of these. This is how you're going to identify and refer to floors in the room dimensions worksheet. So once you are, let's say I'm doing a floor in the, or a room in the heated crawl space, I would enter in HC here. I mean, you're going to see the available ones show up there just like before, but yeah, HC is how you specify the heated crawl space. Okay, so strongly recommend to read through all of these hover notes here. It's going to show you a summary of the area and volume. This software separates out heated crawl space area and volume now from the living area and volume. These inputs are all similar to before. If you want more information, again, read the hover notes. Air tightness. One difference now with air tightness is we're giving you multiple options for entering in the air tightness of the building. The first one you can choose is to select from a list of values, right? So if you don't really know what the house is going to be for, or if you know that it's going to be for exactly one of these, you can choose this, and this is going to be displayed on your results page. If you know the target air tightness of the building, but the building isn't built yet, meaning you don't have the actual blower door data, you can enter in the target air changes per hour here. 2.50 is very common in the BC housing industry today. That's lots of times what we target for new buildings. I have not entered in the building volume, so nothing's showing up here. However, once I do and make other building inputs, these values are going to show up. Now, the equivalent leakage area is an actual measurement taken with the blower door information. with blower door equipment. So if you have blower door equipment, get that from the energy advisor and input it directly. But if you don't have it, you can choose this, and this is going to make an estimate for you of the equivalent leakage area. Again, you should also say if the air tightness value is assumed. These are important to display on the results page, right? Because whoever's looking at these numbers, it's good for them to know that you've assumed this air tightness. Flue penetration, same as before. Again, if you want more information on what this is, you can hover over these notes. There's also a tool you can use here. If you have non-circular flue penetrations, you can enter in the total area of them. You know, the example here would be like a fireplace, a lever vented fireplace, right, with a, let's say, 4-inch by 20-inch opening. This will give you the equivalent diameter of a circle. So if I wanted to enter in that fireplace flue opening, I would just type in 10.09 here. Ventilation types. When you select from the list, it's important to actually read these before you select to make sure you understand which one you're going to have in your building. If you're wondering about fresh air supply, you can hover in over there, right? This is a rigid duct from the outdoors tied into the forced air return plenum. When you're specifying your ventilation amounts, we provide some tools here this time where you can find the minimum requirements depending on different building standards. We got BC Building Code here, ASHRAE 62.2, CSA F326, and the new National Building Code 9.32. So it's very important to note that whatever numbers you get here, right, this is all going to be automatically calculated once you've done all the earlier building inputs. We haven't done that, that's why we're not seeing anything here. Once you've made those building inputs, you're going to see numbers here. It's important to know that these are the minimums. So we're not just arbitrarily saying, oh, the minimum is 16, so I'm just going to type in 16. That's not what these are for. These are for telling you the code minimum requirements. However, that's probably not going to be what's installed in the house. It's very rare for a contractor to install a ventilation system that meets the requirements exactly to the number. You usually err on the high side a little bit and overventilate by a small amount. Select the heating and cooling system type here. If you choose a system with radiant heat, you're going to have to also enter in this information. Humidity, CSA says that most of our buildings can be designed with a 1.3 latent load multiplier. This is for cooling only. If you want more information, or if you want to maybe specify a custom latent load, you can read this comment bubble here, and you can do some research online about that. Next up, we're on to our building elements. So you can treat this section as a library. I'm going to zoom out a little bit. So this is our above grade elements right here in this light blue section. There's a list of saved elements, or I can choose to define any elements with 3 different methods. So list of saved assemblies. Right now I have a saved 0. But yeah, you might have a software you've got a bunch of these filled out for different buildings, different code standards. Maybe you can have the code minimum ventilation, or sorry, the code minimum walls, ceilings, foundations, everything like that saved into here. You can also move them around, right? So you can use this as a library better than the previous software. You can save Excel files with lots of assembly types specified already, and then just refer to them later, or refer to them in the dimensions sheet later. Now, we give 3 different ways for defining assemblies. Everything you need to know is in these hover notes. However, I'll give you a quick overview. Method 1, this is if you know the effective thermal resistance of the element. So if I'm building a wall, if I'm looking at a set of drawings for a new building, and the architect has specified the wall construction, and they've also given me an effective thermal resistance of that wall, right? Maybe they've named it wall-1A, and they could tell me the thermal resistance of the wall was, maybe it's 3.12 or RSI. Actually, this is a good time to show you too. These are cells now. Another improvement from the previous software, right? I want to define RSI here, but I've chosen imperial, so it's R value. So I have to convert that somewhere. Well, I can use up here to do that. So I can convert R to RSI, or RSI to R. So I could type in 3.12 RSI, and that's 17.72 R value. So I would come down here, 17.72. Or maybe I know the conversion directly. I can actually just type it right into this cell, equals 3.12 is RSI. If I want to convert RSI to R, I multiply it by 5.678. It's going to do that calculation in the cell. Maybe I have a header as well. Lots of times the header will have a higher thermal resistance than the wall. It's actually rare for architects to specify these, but if they do, you can type it here. Maybe it's 19. And then I can save it as type 1. It makes a note that if I'm defining a header simultaneously, which I am, it's going to save the wall and the header. So I click yes. You can see this is the name of the wall. I haven't given any description for it, and this is the R value of the wall, and it also defined a header as well. That's method 1. Known effective thermal resistance. Method 2, choose from a list of common assemblies. This tool we built to help with existing homes. Lots of times we're making assumptions in existing homes and we don't necessarily know each component. We don't know if it was 3/8 inch sheathing or 1/2 inch sheathing, so we're making some assumptions along the way. We've made a really fast tool for doing these inputs. So basically, the first thing I do, again, read through these instructions, read through the red notes, but I'm not going to spend the time reading these for you. Select what type you want to define, so wall, shielded wall, interior foundation wall, ceiling under attic, etc. There's all these different types here. We're going to do a wall. And then you just select out of these commonly used options. So I've got 1/2 inch gypsum as my interior. I've got 2x6 walls, 16 inch on center, R20 bats in the walls. I've assumed 1/2 inch sheathing, plywood or OSB, and softwood siding on the outside. This will be vinyl. Oh, sorry. This will be soft. This will be wood. Vinyl's above it. So once I've made all those inputs, I come up here and I can save it as type 1. You can see it says it's a summary here of what I've defined, all of these types, including the air films, right? Effective thermal resistance of the assembly is here. The header is not showing up right now, but that's because I didn't say that I want to define the header simultaneously. If I do, and we do recommend doing this, it calculates the insulation value of the header. These are CSA verified calculation methods for effective thermal resistance of assemblies. And then I click save. Same as before. If I save the header, it's going to overwrite what was there. So you know what, I'm not going to save as type 1, I'm going to save as type 2. So now I've defined the second type. Okay, so I can save whole libraries of things here. Maybe you work with common builders or architects and you know the different assemblies they typically use. Or maybe you know that we build to code minimum most of the time. Or maybe it's different wall types depending on the step code level you're targeting. You can save these and you can actually move them around as well. So let's say I've defined wall type 9 that I actually want to use now as wall type 1. Well, I can go, first of all, I can move wall type 1. So I select wall type 1, move 2. Let's move it to 3. And I would click move. So it's moved that one down, and then I could actually move, let's say I had defined a type 9, I could move that up to type 1. This is handy as well if you do jobs where things can change with new buildings as they're getting built. Maybe you're working with the architect and the builder to reach a certain energy performance. You might be working with the energy advisor as well. You can tweak things and move assemblies around as needed and leave your inputs here, right? Maybe you've referred to wall type 1 and header type 1 over here, right? This is similar to before, the previous software, right? You can change what wall type 1 is and you can move them around. So yeah, use these as a library. The last method we have for defining an assembly is build a custom assembly. So this is component by component. And some of the common things we have here, for example, quick R values for air films, 0.68 for inside of walls. So I could go air inside walls, 0.68. I can just type it in directly. Outside air, 0.17. Okay. And then I can input all the other components of the building right now. And let's say I can even type them out. So I would have my inside air film, then I would have 1/2 inch gypsum, then I might have 2x6 at 16 on center, R22 batt, then I might have 1/2 inch plywood sheathing, then I might have hardy siding, right? And then I just need to find these. And maybe I can find them online or from the drawings, or you can search for them with the tools down here. So there's 2 different search tools. Number 1, search for continuous mediums. That's anything. You think of studs and insulation in between the studs. There's thermal bridging through the stud, right? So it's a complex calculation for the thermal resistance, the R value. Drywall, exterior foam insulation, sheathing. These things are continuous. So we search for these in tool number 1 here. So let's say I wanted to search for 1/2 inch gypsum. I'm going to search interior finish, gypsum board, gypsum lathe, and type in 0.5 inches. Or maybe I have 3/8 inch and I don't know the decimal for that. Again, this is a cell, so I can go equals 3/8 and then type enter. The R value is going to be 0.34. And then I choose the component I want to save it to, component 2, and click save. You can see it sent that right here, so I don't have to type it in manually. Okay, next up, 2x6 walls, 16 inch on center, R22 batt. That's a little bit of a complex calculation. Now, I can come over here and take a look and see if it's in these common R values. So quick R values. Wood framed walls with the CSA default for softwood. And we'll see if we can find what we have. 2x6 walls, 16 inch on center. So these are 2x4 walls, 2x6 walls. 16 inch on center is here, 24 inch on center is here. So here are my 3 options. Ah, look at that. 2x6 walls, 16 inch on center, R22 batts. Effective R value of that component is 15.54. So I can type this directly. That was one of the quick values that's saved here. We also have some guidance over here on typical order of things for different assemblies. Fiberboard siding. Right, I could get that right here. 0.77. Okay, let's see this a different way though. Maybe I've got a different assembly that's not in here. I want to search for it. So that's where I use tool number 2 here for a non-continuous medium. That's any time you have framing and insulation or any component basically that are not continuously arranged in series, one after the other. When you hit studs and insulation, it's not continuous anymore. So the different situations we might have that is walls, vaulted and flat ceilings, right? Again, you've got insulation with some sort of structural stud or joist. Floors, again, insulation with stud or joist. Framing with cavity insulation and insulation beyond framing. So that would be like an attic, right? You might have an attic with 2x4 trusses. So you've got insulation coming up 3.5 inches, but then you've got another 14 inches of insulation on top of that. We can use this here. Or a floor header. So this is like the rim joist space. So let's do that wall that we had up there. I'm going to select softwood. You can also choose from any of these options here, including steel stud. We know it was 2x6 walls at 16 inch on center. Again, these read through all the hover notes and everything. Click on this to see the dimensions. There's options. That's what this blue OR is for. It separates options. I can choose a type, or I can specify the R value of my wood. So I don't have to choose here. I could just specify a custom R value if I want to do that. Same with down here. I can choose 2x6 as 16 inch on center, or I can enter in the width, the depth, and the spacing based on this diagram. The last option, if I just enter in the percent area framed and the depth of insulation directly. Pretty common to just use the first selection option. Last up, I need to define the insulation. So I've defined the framing material over here in step 1 and 2. Now I need to define the insulation in step 3. I have batts in my walls, and it is R22 bats. If I can't find exactly what it is here, I can enter in custom value here. So what is the thermal resistance of the insulation? Let's say I somehow squeeze 28 into there, and the depth is going to be 5.5. So I could choose to do that as well. Or I can, instead of entering the depth, I can check to say the insulation spans the full cavity. But that looks good to me, 15.54, just like we found over here. And again, I can just save that to component number 3, and it's going to send a description of this whole thing that we just defined as well as the R value. Okay, so that's defining a custom assembly. This is what we recommend if you have a new building with like prescribed construction, but you don't have an effective R value from the architect. Okay, fenestrations. This is very similar to the previous version. Windows, skylights, doors, shadings. This is very straightforward. I'm not even really going to go through it. You can use this library exactly how I described this one above. And then down here, you select what type of fenestration you want to define, including shadings. This is where you define shadings. Right? And then you just type in the ID and click send, click save, and then it sends it over here. Okay. Last up is foundations. You have up to 4 foundations that you can define now, and you define them down here. First, select if it's going to be a basement, lowest floor, or heated crawl space. And then you choose what type of foundation it is. Is it slab on grade, concrete slab and walls? This is basically all you see, right? Concrete slab, wood walls. This is talking about your actual foundation walls against soil. Wood floor against soil and wood walls. So that's pretty rare, right? Most of the time, especially for new buildings, it's all concrete. Select your insulation location. So maybe I've got a basement with a foundation, and I've got interior wall insulation only. If I had defined an interior foundation wall, maybe I defined it as type 1, I would be able to just select it here, and I don't have to type in the R value myself. However, we didn't define any, so there's nothing to select. So maybe I've got 12. Then, using these arrows, I choose my foundation configuration. This is just a dimensional diagram. It shows you how the foundation dimensions should be taken. And we enter in only 3 inputs now: the area, the full perimeter, and the exposed perimeter. Define the temperatures for the foundation. Type in the foundation ID number, and then click Save. And that will send the foundation over here. So that's a summary of the building information worksheet. And remember, if you're ever stuck, the hover notes are your best friend. They will probably answer your questions.